Hey guys, welcome to Unit 11, all about polynomial functions. We're going to be starting on page 1 in our new green packet that you should have taken today. If you were absent today, you can find the blank packet on Schoology. If you just want to follow along, you don't have to print it out. You could just print out the first pages if you would like, or you could just look at it, but definitely should be taking notes. The first thing that we're going to be looking at is just introduction to polynomial functions. I want to remind you guys for this first section warm-up, we're going to be doing a sketch. So I want to remind you guys the difference between a sketch and a graph. Okay, I'm just going to do one of these with you. So create a rough sketch. Let's do the first one. So y equals x cubed. Okay, so if I look at that graph, all I want to do, and let me just get standard zoom, okay? All I want to do is show the general picture. What does this graph look like? I don't need grid lines, I don't need numbers. I need shape, I need direction, and I need intercepts to be correct. So I'm starting at the left, it goes up. It flattens out a bit right here, and then it goes up again, okay? That is a sketch, all right? What is important is that we do see that this does have an intercept, an x-intercept right here in the middle, okay? And if we did look at the table, it looks like the intercept is about 0, and it is. It does cross at 0, 0. Remember that any intercept is where the opposite variable is 0. So the x-intercept would be where y is 0, and that's what we see in the graph and on the table. Okay, so what I would like for you guys to do are these next two sketches. Okay, so pause the video, take a minute, do those two sketches, and then see if you can come up with a conclusion about A, B, and C. I'll give you a hint. I want to know how many possible solutions could a cubic have. Okay, once you finish those, let's move on to page 2. We're going to be talking about all the different characteristics, and most of these things are a complete review from earlier in the year and from Algebra 1. So first thing I'm going to do is put this function into my calculator. Okay, and let's look at the graph. All right. Now let's fill in these boxes. Parent function. Okay, remember that means like the most basic version of whatever type of function it is. What we really are looking for is what is the degree? Is it an x? Is it linear? Is it x squared, quadratic? Is it x cubed? Is it cubic? Is it a log? Is it an exponential, which would be a number to the x power? Well, this is not in simplified form, but in order to, if we did multiply this out, we would have x times x times x. So this parent function would be x times x times x is x cubed. So this is a transformation or a shift on an x cubed function. All right. Now, if we look at the graph on the calculator, we do need an accurate graph here for this one. This is not a sketch. There's grid lines here. So I'm actually going to go into my table and I'm going to plot whatever points I can. So I see 0, 0. I see -1, 0. I see +1, 4, 2, 0. Okay, -2, 16 will not fit on the graph. So let's go positive. +3, -24 won't fit on the graph either. All right, so now I just need to use those few points that I was able to plot and graph it. All right, so I do see that it is coming down. We got to make sure that it's coming down before x equals 2, because remember at 2 it was going to be something up here that didn't fit. Okay, so we got to make sure that we're not crossing that line. All right. And then between -1 and 0, we do see, if you look on the graph, it does dip below, but it doesn't hit any other points. So we're just going to do a little dip like this. Okay, then we're going to show it come back up here and then back down here. And then again, we got to make sure it shoots down and it does not cross x equals 3. Okay, because at x equals 3, the value was negative something that's we're not going to actually see on the graph. So we cannot cross that line. All right, so here we go. Zeros. Remember that zeros are the solutions, the roots, the x-intercepts. So there are 3 of them here. You could tell by looking at the graph, or we could also tell by looking at the table. There are 3 zeros where y equals 0. They occur when x is -1, when x is 0, and when x is 2. Okay, and we're writing those as a solution set. Turning points. How many are there? Let's see, we're going down, 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 down. We turn and start going up. So that's 1. And then we go up, turn, and we come back down, and now we're going down forever. So there are 2 turning points. Okay, and we'll talk more about that tomorrow. Domain and range. I want you guys to fill these in. You should know these ones by now. Okay, so that's something that I'm going to have you guys fill in a minute. Increasing and decreasing interval. So remember that we always read a graph from left to right. So where is it increasing or decreasing? Well, if the graph from left to right is going down, this is decreasing. We reach this point here, and it's increasing again, right? Or it starts to increase. And then we reach this point here, and we start to decrease. So let's figure out this increasing interval first, okay? We're increasing from here to here. And remember, any intervals, we are always going to use the domain, the x's. So this is actually increasing from 1, and it stops increasing at 1. Oh, I'm sorry, I meant for this one to be a -1. So from -1 to +1, or what? That's actually -1/2. I'm sorry. From -1/2 to +1, that's where we are increasing. Okay, and decreasing, there are actually 2 decreasing intervals. We're decreasing here in this beginning, and then after 1, we're decreasing again. So you could have 2 different answers here. Okay, one of them is from 1 to infinity, which technically would be, let's rewrite that, x is greater than 1. Okay, that could also be from 1 to infinity. It's also decreasing when x is less than, oops, and I made a mistake here. This should be x is greater than 1. When x is less than 1/2. So that would be from -infinity to -1/2. Oh my goodness, I'm making so many mistakes today. Right, so from -infinity to -1/2, this is decreasing. Okay, that's this one. And then when x is at 1, it starts decreasing again. So when x is greater than 1, it is also decreasing, and that's this interval. Okay. We will talk about degree and leading coefficient tomorrow. All right, but remember, I want you guys to fill in domain and range. Remember, domain is x, left to right, and range is y, which is really bottom to top, right? It's always low to high. All right, let's look at one example. Let's look at skill number 1. Okay, the first thing you're going to do is graph whatever it is that they're asking you about. So 0.5x to the 4th plus 3.67 x cubed minus 98.25 x squared plus 343.1 x. Now, it could be an ugly graph like this, okay? and we can't see it all when we go to it. So you could always press zoom out, which is 3, or you could do zoom fit, which is 0, and that might just give you like a better picture of it. Okay, now they're asking you over what interval does the graph strictly increase. So on whatever interval they're showing us, it should only be increasing between those x values. So from 0 to 2, is it increasing or decreasing? Well, on a graph like this, it's kind of hard to tell, so you might actually want to look at the table. Okay, so from 0 to 2, are those numbers going up or down? It's going up, and that's what increasing means. So guess what? That's it. Okay, well, let's just quickly go through the other answer choices just to kind of show you what would not be right. The next answer choice says from 0 to 3, but when we get out to 3, isn't that number decreasing again? We're going from 330 to 284, so that's not strictly increasing. Okay, it's going up and then down, so no good. From 2 to 5, well, from 2 to 3, it's going down, 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 so that is strictly decreasing. Okay, and same thing from 3 to 5. It's only decreasing. All right. So I would love for you guys to do exercise 1 on page 3. Okay, same kind of concept that we just did. So what I need you guys to do, make sure that we understand the vocabulary. You guys should know how to find zeros, turning points, domain, range. We should know what increasing and decreasing intervals look like on the graph. Okay. And we should know how to find increasing and decreasing intervals. All right, so you guys are sketching these two. Answer this on page 1. Domain and range on page 2. And exercise 1 on page 3. Okay, I will see you guys tomorrow. Let's get ready to get through Unit 11.